Hi, today we'll be looking at electricity, okay? What electricity is. So electricity is a phenomenon that deals with charges, all right? Electricity has been studied over the past 200 years by various scientists such as Michael Faraday, Volta, Ampere, Lenz, Tesla, all right? This study of electricity began way back in the 1800s, okay? And today we enjoy electricity and we use it in various devices. But here we want to look at what really is this electricity? What is the concept of electricity? Okay? So as we have seen so far that it deals with charges, all right? Now, it can exist in two forms. The first form is called electrostatics, which is also static electricity. That means electricity at rest. Anytime you hear statics, it means at rest. When something is static, it's not moving, okay? So that is one form of electricity. The second form of electricity is current electricity. That's just the opposite of the first one. So current electricity is electricity in motion, electricity that is moving, okay? Now, this static electricity, it deals with charges, okay? Both positive and negative charges, which are at rest, okay? Now, some of the things that we normally look at under electrostatics, they include electric fields, electric potential, okay, capacitors, etc. Those things are studied under electrostatics. Now, for current electricity, it deals with the flow of electrons, that is in metals, okay, or ions, okay, this is ions, or ions in liquids, okay, that's current electricity. Now, these electrons that flow, okay, they do that by moving along wires. Those wires are called conductors, all right? Now, I want you to note something, that whenever current flows along a conductor, there is always magnetic field generated around the wire or around the conductor. So, for instance, if this is a piece of conductor this way, and current is flowing within this conductor in this direction, now it has been observed that there will be magnetic fields generated all around this conductor as the current is flowing inside the conductor, okay? So this concept now tells us that current and magnetism are interrelated, okay? So that deals, or that leads to a special branch in physics called electromagnetism, okay? Now, this electromagnetism is a topic or a part of electricity that shows how electricity and magnetism are interconnected or interwoven, all right? So take note of that. So the next thing we're going to look at now is this. I'm going to look at insulators, semiconductors, and conductors, okay? Now, every material that we know, every substance, we can group them into two classes, either as insulators, as a semiconductor, or a conductor. Now, in earlier study, we know that materials are either insulator or conductor. But as you study or advance in your learning, you will discover that there is another type of material which is neither an insulator nor conductor. That material is called semiconductor. Okay? Now, what are insulators? Insulators are materials that do not allow current to flow through them easily. Okay? The reason is because they do not have free electrons. All right? So, current does not flow easily in insulators. Now, insulators have very high resistance. Okay? The resistance in them is very high, so current finds it difficult to flow through them. Okay, so take note of that. The next material I want to look at are called semiconductors. So semiconductors are materials which fairly allow the flow of electricity through them. Okay, they allow current to flow through them, but in a fair manner, not as much as in a conductor. So these semiconductors, they conduct, but do not conduct as well as pure conductors. Okay, so semiconductors are said to have electrical properties that are between those of conductors and insulators. So the electrical conductivity is midway, is half between a conductor, which is at the higher level, and insulator, which is at the lower level. So insulators do not conduct at all. Semiconductors conduct, but not as high as conductors. Okay, so the third material that we have, they are conductors. Okay, conductors are materials that do what? That allow current to flow through them easily. And the reason why conductors are better carriers of electrons or electricity is because conductors have free electrons. Okay, they have free electrons. For example, when you look at aluminium has 3 electrons at the outermost shell, is that not? So the same thing when you look at copper, silver, and the like. Okay, now conductors have electrical resistance, but the electrical resistance in them is very, very low when you compare them to insulators. Insulators have high resistance, but conductors have low resistance. Okay, but even among metals, there are metals that are better conductors than other metals. So metals that we know generally, they are conductors because metals have free electrons in their outermost shell. Okay, now the best conductor of electricity, okay, so far, the known conductor that is very, very good in conducting electricity, the first one that we know is silver. So silver is a very, very good conductor of electricity. So the next one in the hierarchy is copper. Okay, so copper is also the second best conductor of electricity. So we have other good conductors like aluminium, okay, like iron. All right, so we have them like the other metals. So I will see you in the next video where we'll look at some of the terms associated with electricity. Okay, then we'll continue in that way to the calculations in electricity, electrical energy, electrical resistance, electrical power, okay, and electrical circuits. So see you in the next video. Have a nice time.